This last presentation in the Groundwork playlist will consider the hardware side of the design equation, what's inside an FPGA. After watching this presentation, you should be able to explain what are the main architectural building blocks in Xilinx FPGAs, what's inside the configurable logic blocks, and what FPGA resources will be required to implement the 2 to 4 decoder circuit. We will present an overview of the FPGA architecture, followed by further functional details, and to close we will look into the resources used by Vivado to implement the 2 to 4 decoder in the Arctic 7 FPGA that equips the Basis 3 board. So let's start by the architectural overview of an FPGA. In general terms, we can describe an FPGA as a programmable device supporting the implementation of a wide variety of digital systems, which can extend from very simple combinational functions, such as the simple 2 to 4 decoder, up to multi-core computing platforms. The building blocks provided for this purpose are of three types: configurable logic blocks, interconnection resources, and input-output blocks. Each configurable logic block, or CLB, provides a small number of programmable resources comprising lookup tables, assorted logic gates, and flip-flops or latches, but the large number of CLBs available enable the implementation of fairly complex circuits. This is possible by combining an appropriate number of CLBs, which will be interconnected using the local and global interconnection resources that are also represented in this slide. Xilinx provides two main documents of interest with respect to understanding how an FPGA works, one of them being referred in this slide as the source of the image shown. I find the other one that will be referred later preferable, just in case you decide to read them. The interconnections established among the CLBs are vital for the implementation performance, namely in terms of propagation delay. Selecting the best possible interconnections is actually a very complex process, but everything that is done at this level is invisible to the user, since Vivado takes care of all placement and routing tasks. This slide shows that each CLB comprises two identical blocks called slices, which use the switch matrices to connect to equivalent blocks in other CLBs or I/O blocks. Notice the reference to the second Xilinx document containing relevant reading material about FPGA architectures. In order to understand how the programmable resources allow the implementation of any logic function, we have to look inside the so-called slices. Each of these blocks contains 4 lookup tables, besides 4 flip-flops, updated at the rising or falling edge of the clock, and 4 additional storage elements that can either be used as edge-triggered D-type flip-flops or level-sensitive latches. The 6 input lookup tables may be seen as arrays of 1-bit memory positions that enable the implementation of any logic function with 6 inputs. Actually, part of the slices, the so-called slice M blocks, allow the lookup table structures to be alternatively used as distributed memory, as we will see later. This does not happen in the other type of slices called slice L blocks. This slide shows the logic resources available in the Arctic family of FPGAs, which is the type of device used in the Basis 3. This board uses the Arctic 735T, which is a mid-range device with 5200 slices. You may pause the video for a moment at this point to realize the variety and complexity of the logic resources made available by this Arctic 7 family. But modern FPGAs are not limited to CLBs and interconnection resources as shown in this slide. They also provide more complex building blocks, such as digital signal processing structures, phased locked loops, dual-port RAM blocks, and more. We will not make use of this type of resources in our course, but you should be aware of their existence. Now that you have an overview of the global resources available in modern FPGA devices, let's look into some functional details. As you may have noticed in the table showing the variety and number of resources made available in the Artix 7 family, the Slice M blocks enable a considerable amount of distributed RAM and shift register structures. The same table also shows that Slice M blocks correspond to approximately 1/3 of the total number of slices in the FPGA, since part of the CLBs contain one slice of each type, while the rest contain 2 Slice L blocks. To summarize, you may keep in mind that each CLB comprises 2 slices, making up a total of 8 lookup tables, 16 flip-flops, of which 8 can be used either as flip-flops or latches, as well as dedicated carry logic to implement fast arithmetic addition or subtraction, plus RAM and shift registers that can be set up using the lookup table resources of the Slice M blocks. The schematic representation of the Slice M blocks is partially shown in this slide, and you may check the source information indicated here for more information. Likewise, in the case of the Slice L blocks, which differ only on the lookup tables part, as shown on the left. The blocks to the right of the lookup tables implement the carry logic and the storage elements, with the flip-flops in the middle and the flip-flops or latches in the rightmost position. To conclude this presentation, we will see how these FPGA resources can be used to implement the 2-to-4 decoder. For this purpose, we will consider the data flow representation of the decoder. You may also recall that Vivado Synthesis converts this data flow model into the generic technology representation shown here and estimates that a total of 10 cells, 7 I/O ports, and 13 nets will be needed to implement the decoder function. Now, this slide shows how the VHDL description provided was actually implemented. Notice that it uses 4 lookup tables with 3 inputs each, and that the resources needed are actually 11 cells, 7 I/O ports, and 14 nets. You can also see that the lookup table highlighted at the bottom is shown on the left as being implemented in a CLB located in column 2, line 12 of the FPGA structure. The resources used in this CLB and their interconnections are shown in this slide. And this is the end of the FPGA, of our introduction to the FPGA fabric. Thanks for your attention.